PAL-XFEL laboratory was established in 1988 by Pohang University of Science and Technology. The first facility, Pohang Light Source, was established in 1995. This was the first light source in Korea. The original purpose of Pohang Light Source is to make Korean scientists have a competitive edge in their fields. The Korean government decided to make a new machine called PLS-2, which now have 35 new beam lines. More than 60,000 users around the world came to Pohang, and more than 15,000 papers published by their research.
PLS-2 has 3 experimental stations dedicated to protein crystallography. We have contributed to the understanding of life at the molecular level by determining important protein structures. More than 1,000 protein structures have been determined by using our facility since 2002. Pharmaceutical companies want to use X-ray crystallography to see where the compound is bound and how the compound interacts with their target proteins. X-ray crystallography is the most sensitive way to see fragment bindings among the known biophysical methods. This technology depends on the high throughput capability of beamlines, automation technology, and high computing resources. We can expect to do 400 fragment screenings a day.
PAL-XFEL is a very powerful and stable free electron laser source newly added at PAL-XFEL laboratory. This is one more reason why international scientists should come to Pohang.
X-ray free electron laser convert the kinetic energy of a free electron to photons along a very long undulating line, enabling the photon wavelengths to be decreased below 1 ozone. Construction of the facility at PAL was started in 2011, was completed in 2015. PAL-XFEL is based on pulsed RF copper arena with the maximum beam energy of 10 GeV and maximum repetition rate of 60 Hz. PAL-XFEL has independent hard X-ray and soft X-ray undulating line. We have achieved the highest FEL intensity in the world, 1.1 millijoule at 14.4 keV. PAL-XFEL outperforms all other labs XFEL in terms of stability. This includes FL intensity stability and central wavelength jitter stability, as well as the timing jitter.
The timing on the accelerator and laser beam is very accurate. Short-term timing jitter is less than 20 femtosecond RMS. Another good characteristic is the brightness of X-ray beam. The flux of the hard X-ray pink beam is 10 to 11 photons per pulse. Many experimental setups are currently available in PAL-XFEL. For the case of the hard X-ray, X-ray scattering and spectroscopy, serial femtosecond crystallography, microdifraction imaging. In the case of soft X-ray, emission spectroscopy, absorption spectroscopy, and resonance X-ray scattering. At PAL-XFEL, we are welcoming any users to bring in their own experimental setups. We use PAL-XFEL to study materials in the intermediate process of the reaction. The minimum resolution is 150 femtosecond. The typical range of the study is the picosecond to nanosecond.
We hope to grow our XFEL to accommodate more users in the future. We plan to add one more hard X-ray undulator line to double the beam time for the hard X-ray users. We'll increase the pulse repetition rate to 120 Hz to enable more users to use XFEL with unprecedented stability.
Due to synchrotron's high intensity and timing resolution, industry can analyze the products in production condition. There are many potential applications, including semiconductor, battery, cutting-edge materials, pharmaceuticals, and cosmetics as well. This led to establishment of Industrial Technology Convergence Center. ITCC offers diverse services including technical advice and analysis services, technology transfer, and the joint development of technology. Korea's main industrial fields such as semiconductor, energy, chemicals utilize synchrotron. The spectrum of project is very wide. The speed of research and development of industries are very fast and require a very high level of science. Working with industrial firms always challenges us at PAL.